A health researcher wants to examine the relationship between daily screen time, X, and hours of sleep per night, Y, for teenagers. They collected this data. So we've got the screen time and the hours of sleep. Screen time is X, hours of sleep is Y. We want to calculate half of the data, and then in part B, we're going to calculate both the Y on X and X on Y regression lines. So I'm going to need the calculator for all of that. So let's just get the calculator back here. I want to click out of there. I've got my data here, and just going to exit a couple of stages. And when I'm here, I'm going to delete the data from that previous example. So, and then I need to delete. You have to do each list individually, I believe. There may be a way around that. And there we go. And then we can start putting in the data. Now, because I'm going to do both Y on X and X on Y, I'm going to start by putting the X's in list 1. Remember from previous lessons, that's how I've got this set up. We may have a look at that. So I've got 7.7 and 6.9. And I'm going to pause now while I put the data in. Okay, so we have all of the data in. And so we want to go back to calc. Now I'm just going to go into set just to show that my X's are in list 1 and my Y's are in list 2. And let's just execute on that, and we come back here, and then we know we want to calculate regression, and it's X because it's linear, and we want AX plus B. And so we have that our R is, so our R is, let's just get the calculator back, negative 0.876. And then because we've got it set up this way, we are looking first at the Y on X line, and we can see the A is negative 1.243. So Y is negative 1.243x, and then plus 14.541. And that is my Y on X. So now we want to do X on Y. And in order to do that, one way of doing that is to grab the calculator and just change the lists over. So instead of our X's being in list 1 and the Y's being in list 2, change that. So make that one list 2 and make this one list 1. And then that's done. And we can go back to here, go to our regression line, X, AX plus B, and we get the new values. And you can see that what we have is the A is negative 0.617, and then we have the 10.43, but it's X on Y, so we have to have X equals and Y over here. It's easier if you think about it in terms of the variables. For the Y on X, think about it as being sleep equals negative 1.243 times screen plus the 14.54. And then when you do the X on Y, think of it as being screen is equal to negative 0.617 times sleep plus 10.43. Okay, so we've got both of those. Now we're asked to plot the data on the grid below and add both regression lines. So I am just going to pause and put the points on the grid. Okay, so I have the points on the graph. Now for my y on x, which is this one up here, and written that a bit weirdly. So let's just try that again, y on x, and then down here I've got the x on y. I'm going to get 2 points. So I'm going to use y of 4 and y of 8 because I think they'll fit nicely on the graph. And they go across the data, which is always a good idea, just to use as much of the graph as you can. Put these 2 points as far apart as is feasible. And this first one gives me 9.57. I'm just substituting in for x, so x is 4. And then this one gives me 4.60. So let's put those on. So x is 4, y is 9.57, which will be about there. And then x is 8, and we get 4.60, which would be about here. And let's draw it on there, like so. And then for this one, let's do x of 10 and x of 4. I think that gives me a nice span. So what I'm doing is putting y is 10 in here to start with, and I get 4.26. And then x of 4 is going to be 7.96. So for this one, remember, it's x is 4.26, y is 10. So go to y is 10, and 4.26 would be about here. And then this one is when y is 4, and x would be 8, basically. So that is there. And then we want a straight line that goes through those two like so. So the red one is y on x, and the blue one is x on y. So predict the hours of sleep for a teenager who had 6 hours of screen time and comment. Well, we're predicting hours of sleep from screen time, so we want to use y on x. Remember when I wrote it out in terms of the variables up here, sleep, screen. So that is going to give me that y is equal to negative 1.243 times 6 plus 14.54. And that gives me 7.08. And x is 6 is nicely within the data, so that is interpolation with a strong correlation coefficient that should be reliable. Predict the screen time for a teenager who got 9.5 hours of sleep and comment. Okay, so this time we're going to use this line. So our x is going to be negative 0.617 times 9.5 plus 10.43. We'll calculate that. And that gives us 4.57. Now, 9.5 hours of sleep, however, is slightly beyond the data. And so that is extrapolation. It's not extrapolation by far, and I might comment to that, but it is still extrapolation, which would make it less reliable than the other estimate. Now, as the last thing here, I actually plotted the two lines on Desmos, and I zoomed in a bit. And we can see the two lines here. You can see that the red one is the y equals negative 1.243. So that is the y on x, and this one is the x on y. And you can see the estimate when x is equal to 6 for both of them here, and they're not that different. But there is a bigger difference when we try, actually I did 9 here rather than 9.5, but you can see it's a slightly bigger difference out there on that. But it is important to use the blue one for the second estimate and the red one for the first estimate.